Hi, I've been on a big data journey for the last 4 years. And during this time, I've spent time with hundreds of both customers as well as industry professionals, spanning CTOs, CIOs, lines of business folks, IT professionals, as well as, of course, friends from our Hadoop community. And one common theme that I hear from all of them is, yes, we get big data. Most of them they started with maybe tens of nodes of having a Hadoop cluster, expanded that to hundreds of nodes, in some cases thousands of nodes, and have terabytes, petabytes of data now sitting in those clusters. And the chorus that is rising is, but show me the value. Where is the big value in this data? And while everyone gets it that the possibilities are great, they are unimaginable, and I can go through scores of use cases that we have seen across different industries where people are seeing the value. And the underlying theme of all of, or most of these use cases is spotting trends quickly, spotting anomalies, seeing patterns in the data, and be able to do it at very large-scale data sets that you can think of. So this is what people want to do, and now let's see where they are with this. A lot of the initial IT, the big data implementations have been led by IT. So, they bring in commodity hardware, put open source software on it, offload data from warehouses. This could be a warm, cold data. And on the wayside, also pick up data that does not belong in the warehouse. And all of this equals cost savings. But, we are really on the cusp of something much bigger than just doing all of this for cost savings, which is really to derive value from the data. And that need is becoming very real, very immediate, and very pervasive. Everyone wants that. So for that to happen, it's really, the need is for workloads to evolve from batch to more interactive or mixed workloads. Some of the possibilities of what we are seeing with Spark is making that happen. There is a need for iterative discovery and analysis. There is a need for large-scale machine learning and cognitive analytics. There is a need for all of the lines of business to have access to the data. And there is a need for really businesses to go from cost savings to revenue growth. So for this to happen, we've proposed a reference architecture, and we are building on this big data platform. So at the center of this platform is the component that you see, which is being referred to by, I think, many as a data lake or as a landing zone. So in this data lake, you can get all types of data. It could be as elemental as text or complex data like audio, video, geospatial. You can bring in data from systems of engagement. You can bring in data from systems of records like your warehouse or your master data management systems. And this data lake is really surrounded by high-value functional components. These high-value functional components are drawing data from it, as well as pushing data into it. Some of the examples of these high-value components are your data ingesters, SQL engines, text analytics engines, machine learning engines, and obviously a host of very rich applications. Now, what's the cornerstone of this architecture? The cornerstone of this architecture is really cohesion. And by that, what do I mean? That all the components that you have in this platform/architecture. The data has to be accessible to all of these components in a seamless manner, whether it be a low-level map-reduce job that needs to access this data, or SQL that needs to access this data. There could be a batch-oriented application that needs to be fed this data from the disk. There could be an interactive, iterative analytics application that needs this data to be in memory. It's very critical that all of these components have seamless access to the data. So that's one aspect of the platform being cohesive. The second aspect is that all of these components have to interoperate with each other. And let's take an example. Like if you have text data that enters this data lake, there's information extraction that works on this text data, which is unstructured, puts it in a structured form, pipes it to maybe, put SQL on it to do heavy data transformations, pipe it into a machine learning algorithm, and then the same model could be injected back into SQL for scoring on new data. So that's how the data has to flow in this ecosystem, almost like oil, and it takes the shape of the container that it is in. And with this kind of a platform, where data is seamlessly available, accessible to all components, as well as there is interoperability across these components, will really make our big data elephant twist, turn, and dance. So with that, I thank you and invite you to our session and booth to go over more details here. Thank you.